This is Colin Sandberg, and I would like to address something that's been kind of annoying me for a while, which is the idea that kilojoules are the same thing as kilocalories. And the way people talk about this is that you can do a ride and then look at the kilojoules from your power meter and to know how many kilocalories you expended. I feel like this is one of these things that just won't die. I've been hearing about this for 20 years and it's just not true. So I'm going to try to explain this as simply as I can. So let's step through this. Calories and joules are both units of energy. A calorie, that's calorie with a small c, is the amount of energy required to heat 1 cubic centimeter, that's 1 milliliter of water, 1 degree Celsius. 1,000 small c calories equals 1 kilocalorie, also known as 1 big C calorie. So when you look at a food label, those are big C calories or kilocalories. 1 joule is the amount of work required to produce 1 watt of power for 1 second. 1,000 joules is 1 kilojoule. Like I said, kilocalories and kilojoules are both units of energy, and you can do a direct conversion. 1 kilocalorie is just over 4 kilojoules, specifically 4.184 kilojoules. Both are units of energy. It's really just a matter of custom, which custom we use and where. Typically, it's kind of like sometimes we use imperial units, some places you use metric units. We tend to use calories or kilocalories in chemistry and joules in physics, just out of custom. Okay, so when I go for a ride, I do work by applying power to the pedals. If you have a power meter, you can see how much work you do. That amount of work only goes up over time and it never goes backwards. The higher your power output is, the faster you accumulate kilojoules. But you are always accumulating kilojoules over time. So the only factors in kilojoules, that kilojoule number when you go for a ride, are power and time. And at the end of the ride, the work done equals power times time. Specifically, I can say that the work in joules equals average power, measured in watts typically, times ride time, measured in seconds, for the purposes of this. And kilojoules equals joules divided by 1,000. So, for example, 60 minutes at 100 watts is 360 kilojoules. 60 minutes at 200 watts is 720 kilojoules. 60 minutes at 300 watts is 1,080 kilojoules. Just as a quick note, when the power here is average power, not normalized power. It's straight up average. Now when we talk about kilocalories or calories, we're usually talking about it in the context of energy expenditure. You want to have an idea of how many calories that you're burning for the purpose of fueling, right? And body weight management. And yes, ultimately, that does come down to intake versus expenditure. If you burn more calories than you take in, you lose weight. If you take in more calories than you burn, you gain weight. If you're trying to figure out the most effective way to lose weight in a way that doesn't sacrifice performance or cause health issues or make you miserable, yes, it's way more complicated than that. But if we're just talking about thermodynamics here, you can't beat the rules of science. Now, something that's important here is that most of the calories we burn do not go directly into producing power on the bike. So most of the calories we burn during exercise actually go into heat regulation, keeping ourselves cool. We also have to keep sending blood and oxygen to our brain and other vital organs to keep them alive, not just the muscles that are being used to create that power on the bike. In fact, the common estimate for efficiency when cycling is 18 to 25%. And that might sound pretty low, but actually the bicycle is a pretty efficient machine. Um, but that means 18 to 25% efficiency means that only 18 to 25% of the calories of work done go into producing power on the bike. Or to put it another way, for every calorie of work done on the bike, we've actually burned 4 to 6 calories. Our body has. If you remember that one kilocalorie is a little more than 4 kilojoules, that means that we burn 0.96 to 1.43 kilocalories per kilojoule, which is where that 1-to-1 estimate comes from. If we assume a 24% efficiency rate, which is in that 18 to 25% range, then yes, it is 1-to-1. Problem is, that's not a good assumption. It is not fixed, and it's not realistic for a lot of people. How efficient you actually are is going to depend on a number of things. One, it's going to be determined by fitness. The fitter you are as a cyclist, the more efficient you're going to be typically. The problem, well, the one other thing it's going to be dependent on is the terrain. For example, if you're mountain biking, you're going to spend a lot more energy controlling the bike than on a road bike riding down a flat road. 3, the intensity of the ride. Higher intensity is going to be less efficient typically, mostly because your body heats up more, so you have to spend more energy. The harder you go, the more your body heats up, the more energy you have to spend staying cool. 4, the type of intensity. A non-steady state ride, like a cyclocross race or a crit, will be less efficient. Remember that kilojoules at the end of the ride only reflects average power in time, not normalized power. So from a metabolic standpoint, any of those rides with a big gap between average and normalized are going to be less efficient. And finally, heat and hydration. If you're overheating or dehydrated, you obviously have to spend more energy to stay cool. So the actual efficiency is a bigger range, really, than 18 to 25%. If you think about it, it can actually be as low as 0. If you're not applying any power to the bike, like you're coasting down a hill, you're not doing any work, but your body's still burning energy. In terms of average efficiency for a ride, I think that if we're talking about experienced riders here, we have to drop that bottom to around 12 or 13%, and even less for inexperienced riders. And at the other end, that 25% efficiency that we're close to assuming to get that 1-to-1 ratio really is only true in the extremes. Like, we're talking a pro cyclist here, somebody really, really fit, on a steady, flat endurance ride on a cool but not too cold day. So if you finish a ride and your power file says 1,000 kilojoules, you might have burned 960 calories, and you might have burned 2,000 calories, really. In other words, to assume the 24% efficiency, I think is just, it's ridiculous. So, is there a better way? Actually measuring expenditure would be impossible unless you're in a perfectly controlled environment and you are able to perfectly measure the content of all solids, liquids, and gases coming in and out of your body. The gold standard here is a method called doubly labeled water. Now, I'm not going to get into too much about the specifics of this, but basically you can drink a specially enhanced water and then do a urine analysis to determine how much oxygen is being used. Problem is that this might give you a pretty good estimate of calories burned in like a week or a few days over a period of time, but not really so much in specific activities. So another decent method you could use, not as good, not as perfect as that doubly labeled water, but decent, would be to analyze respiration and look at oxygen and carbon dioxide content, with which I can backtrack from there and get a decent estimate of expenditure, and especially during aerobic exercise, lower to moderate intensity exercise. If anybody has ever had a VO2 max test or seen a VO2 max test, this is the equipment that we're talking about. Problem, of course, is that, simply put, we don't live in the lab. So I think it's obvious that we'd be looking for a shortcut here to try to measure the actual calories that we're burning. And there's no perfect solution, but I'll leave you with a few thoughts on this matter. First of all, I think that a system based on heart rate is better than a system based on power output in terms of correlating heart rate with caloric expenditure. Power is an external measure. Heart rate is internal. Caloric expenditure is internal, and heart rate generally correlates better to expenditure than power output. There's a couple problems, of course. First of all, everybody's heart rate is different. So you can't just say that you burn X calories per hour at a given heart rate. One person might burn 300 calories per hour at 150 beats per minute, and somebody else might burn 1,000 calories per hour at 150. So you have to know yourself. How do you know that? Well, I think a decent way to get an idea is to do a VO2 max test in the lab. Most of those are ramp-up tests. So you can see the number of calories you burn at zone 1, zone 2, zone 3, etc. Through the heart rate zones. Then you can look at a workout file and say, I spent 30 minutes at zone 1, 60 minutes at zone 2, 8 minutes at zone 3, etc. Get a decent estimate of calories for the workout. The problem here is that you probably don't want to do that calculation every ride, and B, this would still just be for the workout when you're wearing a heart rate strap. On the other end, you might use a wearable like a Fitbit or an Apple Watch or a Whoop. Difficulty here is that you're kind of at the mercy of their algorithm that device uses. It may be good. In my experience, I use a Whoop, and I've been using it for a couple of years. I feel like it's pretty good. That's anecdotal, though. That's based on my experience and the experience I've had with some of my coached athletes. The other issue, though, is that a wrist-based heart rate monitor, it tends not to be quite as accurate as a chest-based heart rate monitor. Again, this is anecdotal, but what I will notice is if I've got them both on and I try to compare them, the wrist-based one is it's pretty much right on at lower intensities, like at rest. But when I start going hard, there's a vast difference between the chest strap and the wrist strap. So the Whoop is good because I keep it on all day. Does a pretty good job at estimating my total daily expenditure, but not so much if I'm trying to look at how many calories I burn in a given workout. Number 3, weighing yourself every day can tell you a lot, in my opinion, because there's quite a bit of variation every day based on hydration, mainly from hydration. I would recommend weighing yourself at a consistent time every day. For a lot of people, that's first thing in the morning, right when you get out of bed. But it could also be if you get home from work consistently at like 4:30 p.m., 5 p.m. every day. That could be a really good time to do it too. But this will give you an idea. Take a 7-day rolling average. I think 7 days works pretty well at smoothing out those variations, mostly due to hydration. But this will give you an idea of what your caloric balance or imbalance looks like. Simply put, if you're gaining weight over time, you're taking in more energy than you're burning, and if you're losing weight over time, you're burning more energy than you're taking in. Now, I do want to acknowledge one thing really quickly here, that the act of getting on a scale every day for some people, may take a psychological toll. And I think that's because for many of us, right or wrong, body weight is tied up in a lot of psychological issues, not only in performance, but also in self-image and self-worth. In general, I think that women have it worse, but that by no means means that men are exempt from these issues with external and or internal judgment, disordered eating, everything that goes along with that. So for me, getting on a scale every morning sort of helps numb me to some of that stuff because I start to just look at it like a number. But if you feel like there are negative psychological effects to stepping on a scale, just don't do it. It's not worth it. Um, okay, so point four, if what you're most interested in here is finding out whether or not you're adequately fueling for your workouts, there are probably better ways of telling you that than trying to calculate exactly how many calories you're burning, both in your workouts and in throughout the day. Um, it's close to impossible to take in more calories than you're burning on a ride. The only way that you might get close is if you're riding at a very easy, like recovery pace and simultaneously stuffing your face with as much as you can possibly eat. And you might ask, if this is the case, how come I don't bonk on every ride if it's impossible to take in more than I'm burning? And the answer is that your fat stores make up the difference. Fat is a very it's an amazing way to store energy. There's approximately 3,500 calories in 1 pound of fat, so that even somebody who's really lean has quite a bit of stored energy. The problem is that the higher your intensity, the higher percentage of your energy expenditure is coming from glycogen rather than fat. Glycogen stores are much more limited, and you'll burn through them eventually if you don't slow down, if you're going too hard. Taking in as many carbohydrates as you can while riding will slow that down a little bit, the time it takes till you exhaust those glycogen stores. But you're still fighting a losing battle. So if you want to know if you're taking in enough fuel, ask yourself, did my performance decrease during the ride? Did my heart rate and power start to decouple, meaning that your heart rate starts to rise at a given power, or your power starts to decrease at a given heart rate? Did you feel hungry? Did you cramp? These could all be clues, and I know that it's all of this stuff is subjective. We're talking about feelings, but in my opinion, this is more worthwhile to ask these questions than try to figure out these exact calculations and get a false sense of accuracy here when there really isn't one. And a lot of people have been asking about taking in enough carbohydrates per rides for given workouts. This has been a hot topic lately, and some people even brag about how much they can take in. I know the number 120 gets thrown around as an upper limit for a lot of people. But if you're trying to get to that point, obviously there is a performance advantage in being able to take in as many calories as you can get in without having gastric distress or anything. If you're going to try to do that, you're going to need to train your gut, and you may have to try different products. You may not quite get it right. You might only be able to tolerate 85, 90 grams at first per hour. What I can say is that if you're only taking in 20 or 30 grams per hour, and I know a lot of people who do that, it's not enough, at least on a race or high intensity ride. If it's very low intensity, you might be able to get away with that because you're burning mostly fat. So, bottom line here is that it's hard to measure how many calories you're burning or taking in, for that matter. But if you ask yourself what actionable information you're trying to get from this data in the first place, there's probably a better way. And finally, I do want to say that almost all of us would benefit from speaking with a nutritionist or a dietitian for expert advice here. I don't want you to get the impression that nutrition comes down to just a thermodynamic equation here. It's really complicated when you factor in all these real world factors like eating during exercise, different weather conditions, allergies, dietary restrictions, disordered eating, uh, gender differences, nutrition periodization, etc. So talk to a nutritionist or a dietitian who is trained in all of this, and you might find that there's some real performance gains to be made. Okay, thank you. Please like and subscribe to the EC YouTube channel. Thanks for watching.